Welcome all. I'm Dinesh Kumar, studying BE Mechanical Engineering, third year in Coimbatore Institute of Technology. Today I'm going to present topic on types of shaping machines in the subject of manufacturing technology and surface engineering. Let's go on the topic. Let's see the topic types of shaping machines. You can see that we can see the history of shapers. Samuel Benjamin Briggs engineer developed a shaper between 1791 and 1793, and later James Nasmyth, British engineer known primarily for his invention of steam hammer. He invented this picture showing the steam hammer used for forging, shaping, which is that the invention of shaper has revolved in our world in 1836. You can see a couple of persons are rotating wheel. It's a simple mechanism in which the hammer, see steam hammer, in which the ram is goes down and up in the simple mechanism. In the other side, there's a person which are moving the workpiece, so the ram can be uh, came with a high force, so it can shape with the required shape. So that the steam hammer as discovered by James Naismith. Let's see what is shaper machine. A shaper is a type of machine tool that use linear relative motion. You can see that linear relative motion between the tool and the workpiece. During the forward stroke, the ram is holding the tool, is reciprocating over the workpiece to cut into required shape. During return stroke, no metal is cutting. Why means there is a clamper box which is attached to the single point cutting tool in which the forward stroke it is a metal is removed. During return stroke, the clamped box is lifted so that no metal is cutting. No cutting operation is performed in quick return direction so that we can production rate can be increased. In the shaper machine, the rotary motion of the drive is converted into reciprocal motion of the ram holding the tool. See, you can see the rotary motion of this motion is converted into reciprocal motion. Next, we can see some difference between a shaper and planer machine. Shaper. A shaper is used to machine smaller workpiece, whereas planer is used to machine larger workpiece. In shaper, tool is moving and workpiece is fixed, whereas in planer, tool is fixed and workpiece moving. Shaper is a light duty machine, whereas a planer is a heavy duty machine. A planer only one cutting tool is allowed to be used, whereas in planer more than one cutting can be equipped at a time in a planer. Shaper is less rigid and give poor accuracy. Surface finish also poor. Planer can give higher accuracy and give high productivity. Productivity means rate of production can be increased compared to shaper. The shaper machine can create a flat surface on both horizontal, vertical, angular, and contour surface. This is a contour surface. The planer machine is suitable for big casting, heavy forging, etc. Next, we see the type of shaping machines. Shaping machines are the reciprocating type of machine tool in which the workpiece is held stationary and the tool is reciprocating forward and backward. Most shapers have reciprocating motion in horizontal position, that is horizontal shapers. But shapers are also designed with reciprocating motion in vertical position. That is called slotting machines or vertical shaper machine. You can see that types of shapers later. Let's see the shaping operation. Normally, doing the forward stroke, the clamp box is attached to the tool so that metal cutting can be performed. While return stroke, I already say that the clamp box is lifted. You can see the difference between the forward and return, so that there is no metal cutting is performed during return stroke. So the rate of production rate can be increased. As the RAM, consider as the RAM move at a faster rate during return stroke, the time taken become less. The total timing decreases and the rate of production increases. You can doing the return stroke, it is a quick, so that the production rate can be increased as much as the following mechanism are used for quick return of the RAM. These are following mechanism. There are basically three. One is crank and throttling mechanism, and the second is hydraulic mechanism, which is used hydraulic mechanism in which oil is used as a working substance. That is the input mechanism. You can see that briefly. Here we can see that crank and throttling mechanism setups. Here is the, you can see the component bull gear. This is a driving pinion. This is throttle link. This is a crank, it is a bevel gear, it is a crank pin, and it is a sliding block. It is a ram and a tapping lever and a hand wheel for cushion of stroke adjustment. You can adjust it. I can explain the principle. Here is a electric motors, which is attached to the driving pinion, and the driving pinion attached. The bull gear also attached. It's a power transmitting. Normally, gears are used to transmit the torque power. So using a driving pinion, it transfers the power to the bull gear. So the bull gear is rotated. The sliding blocks are slid here and there, so that rock arm is sliding. The rock arm normally, name is say, rocking forward and backward, rocking here and there, so that cutting operation is done. You can see that in video. Now it is a simple. Before that video, this is a setup. Here you can see that the written is a forward stroke. You can see this is a slotted link, is a sliding block, and it is a bull gear. It's a model pinion setup. It is a slider or rank or a ram rotation. You can see that. And this is the angle ESC. You can see this is the forward stroke. This is a return. You can see the angle 216 degree. It is a forward stroke angle. It is a return stroke angle. This is a normally you can use this angle. Stroke length in a quick return mechanism of the RAM. Let's see. Stroke length of a RAM is the distance the RAM move forward or backward. It depends upon the distance between the center of the bull gear and the center of sliding block. It's adjusted according to the length of the work. Is a total description of the main parts of the mechanisms. The bull gear, you can see it is a lead screw, crank pin, bull gear sliding blocks, and rocker arm sliding blocks. And you can see that bull gear slides and bull gears. This is a video, which you can see the crank and slaughter link mechanism. think you all understand the crank and slaughter link mechanism in this video. Let's move on the topic. Here the quick return motion. It is a alpha is a cutting angle, while beta is a rectangle. It is a pivoted link. It is a slaughter link. The crank pin, bull gear, piston gear. You already seen that. It is a hydraulic mechanism in this setup. It consists of a piston, cylinder arrangement, and a tool head, ram, and a drain pipe with throttle valve, and a reservoir. Reservoir which contains oil as a working fluid, and a leaf valve and gear pump or a pump or four-way control valve, supply pipe, etc. And in this hydraulic shaper, the working fluid is oil. The oil is sucked by the pump at high pressure. High pressure, the oil is sucked and is go to the right hand side of the piston cylinder, on right hand side of the cylinder, where it at under high pressure, the forward stroke is performed. While at the return on the left hand side of the cylinder, the remaining oil left on it is come into this pipe and it goes again to the reservoir. It's a control, speed control. It is a throttle valve which will control the speed of this hydraulic machine. And while performing a forward stroke, and at the end of the in stroke, there is a shape for dog, which is hit the reversing lever so that cyclic cyclic production can be done. Cyclic metal can be done in this hydraulic shaper machine. While the forward stroke and the end stroke, at the end of the end stroke, there is a shaper dog which hit the reversing lever so that a cyclic operation can be done in the hydraulic shaper machine continuously. It is a smooth operation in which working fluid uses a oil is sucked at high pressure by using a gear pump or a pump so that it goes in the piston cylinder arrangement. At the end of the piston connecting rod, it is connected to a ram so that performance can be quiet and it can be constant because you can all fluid is flowing at a constant pressure. Uh, Here you can see the speed control using a throttle valve. We can adjust and the reversing lever length of the stroke can be adjusted using the reversing lever. This is a hydraulic machine. You can see that machinery is working. Wait 1 second. So smooth operation. See the oil reservoir sucking the oil using the pump at high pressure. The oil is pumped at high pressure. See there is a delivery pipe goes to the machine. Smooth operation. The piston, at the end of the piston connecting rod, they used a ram so that a forward return stroke can be performed in a smooth and controlled manner. Next, we move on the without quick return mechanism. There is a one video in which you can completely understand the without quick return mechanism with an animation video. You can completely understand.
convert the rotary motion to reciprocating motion and provide a quick speed on return flow. Let us see the main parts of the Whitworth mechanism are work speed, tool, ramp, base, stable, ramp, pinion, crank tube, crank plate, bull gear, connecting rod, forward stroke, return stroke of ramp, sliding block, slides on the slot provided on the crank plate. This crank plate is pivoted at the point head eccentrically. The connecting rod connects the crank pin with the ramp. When the pinion rotates, full gear rotates, and the sliding block slides over the slot provided on the crank plate. Connecting rod converts the rotary motion of the crank plate to reciprocating motion of the ramp. Since the crank plate is connected eccentrically, the crank plate rotates with respect to the point head. Crank and blocked with
In this video, I can completely understand the without quick return mechanism in which the crank plate, the rotation motion of the crank plate is converted into a reciprocating motion using the connecting rod. Okay, let's move on the topic. Work holding device for shaping machines. So some of the shaping devices, that is strip, wedge strip, step block, stop pin, hold down, toe dog, parallel clamp, U clamp. These are the clamping device that are used in the shaping machine. Let's move on the types of shaper machine, in which first we can see crank type shaper machine, in which the drive is crank mechanism. Drive is simply what is the mechanism used in construction. The crank shaper employs a crank mechanism to change the circular motion of the gear. We see in that bull gear, circular motion of the bull gear into a reciprocal motion of the ram. It uses a crank mechanism to convert the circular motion of the bull gear into a reciprocal motion of the ram. The ram carries a tool head at its end and provides cutting action. This is the image on the crank type shaper machine. These are some of the parts you can see. Okay, let's move on that. Gear type shaper machine. In this type of shaper machine, the ram is reciprocating. The ram is affecting due to the reciprocating motion with the crank, rack, and pinion gear setup. The rack teeth are cut directly below the ram, mesh with the spur gear. The speed and the direction in which the machine will transfer depends on the number of gears in the gear trains. Is the gear train, when is the number of gears in gear trains, when doing adjustment, the speed can increase. When there is a less number of gears, the speed is decreased. This is a setup in the gear type shaper machine. This type of shaper machine is not widely using in any industry. Next one is hydraulic shaper machine, in which drive is hydraulic mechanism. Again, this is a, you can see this. In this type of shaper machines, the reciprocal motion of the ram is provided by the hydraulic mechanism. The drive is hydraulic mechanism. The hydraulic shaper uses the oil. Oil is sucked by the gear pump or pump under high pressure. You can see that in the pump pressure, high pressure. The end of the piston rod is connected to the ram. So the cutting operation is performed. The high pressure oil first acts as the one side of the piston. It is one side, or right, left. On the other, causing the piston to reciprocating, and the motion is transmitted through the ram. The main advantage of this type of shaper machines are that the cutting speed and force of the ram drives are constant. It is a constant because the rate of flow of oil is constant from start to end without making noise and operate quietly. And next, we can see the horizontal shaper machine. In this type of shaper machine, the ram is reciprocating. The ram holding the tool in a horizontal axis, that is a x-axis, and the reciprocal. This type of shaper is using for production of flat surface. Normally, it is used for flat surface and external grooves and keyways set. Next, vertical shaper machine or a slotted shaper machine. In this type of shaper machine, the ram reciprocating in a vertical plane. You can see the vertical plane y-axis. The table holder workpiece vertical shapers may be crank driven. There is a drives, crank driven or rack driven, screw driven or hydraulic power driven. These are some of the drivens used in this vertical shaper machines. The vertical shaper is very convenient for machining internal surfaces, keyways, slots or grooves. The workpiece can move in any given direction such as cross, longitudinal or rotary movements. This type of shaper is suitable for machining internal surface, mainly internal surface, slots and keys. Let's see the working of a startup shaper machine in video. This is the image in which the slot is created. So we see the video. Video there there's a person which rotates the transfer speed, so the rotating is rotate, so that different slots can be created on different sides. Next, next we move on the types of shaper machine based on the table design. Standard shaper machine, you can see that. In this type of shaper machine, the table has only two movements. One is vertical and another one is horizontal. To give the feed, feed is normally the distance moved per revolution. Already know that distance moved per revolution. That is why it is known as standard shape permission, or the table is not supporting at the outer end. Next is the universal shape permission. The name is universal. And what and on the shape movements such that vertical the table can be and interact. This uses maximum is more speed at different times of operation and is given the name universal. The name is a universal. Type of shape is commonly tool room works. So you see in this type the metal is forward motion the metal remove backward and opposite that forward. The tool is fixed in the tool head in the reverse direction. That means the tool also in a reverse direction provide the cutting action reverse stroke of the ram. See that in a rocket everything is reversed manner. See the some formula in machine timing. On the cutting speed, we can find the time required to complete one double stroke is given the formula T. The next formula with the speed of with the speed of millimeter cube per double stroke, number of double stroke required to machine a surface with analysis can be calculated. Is total time for machining surface can be also calculated using the T. In terms of stroke, the time for machining surface is given Ts. These are the some of the formula which can be used to calculate different parameters on machining timing. Next, we can also calculate MRR, which is mean by material remove rate, millimeter cube per minute, which can be calculated using this formula. Next, you can see some advantage of shaper machine. A single point tool, which is used in a shaper machine, so it can be inexpensive or we can say low tooling cost. The cutting stroke having a definite stopping point. It has only limited stopping point, not infinite. Torque can be held easily in a shaper machine. The setup is very quick and easy and also can be easily changed from one job. It can be easily we can change from one job to another job. A disadvantage of shaper machine is by nature it is a slow machine. You can see the video of it. It is a slow machine moving forward and stroke. It is a lower speed. It is a low machine because of the straight line forward and return stroke. The single point cutting tool requires several strokes to complete a work. The single point cutting tool requires several strokes because it is a single point, not a multi point. So it requires a number of strokes. So it can be slow process. The cutting speed is not usually very high speed of reciprocating motion due to high inertial force is a Fitch's force developed in the motion of the unit and the component of the machine. Application of shaper machine to produce the to produce a straight and flat surface on the workpiece to smooth the rough surface. It is used to create an internal partition of spines used in making of gear teeth. Shaper is used to make dovetail slides to produce keyways in pulley or gears. These are some of the application of shaper machines. Thank you all for your time, patient. Thank you so much.